Hey guys, today we're going to be looking at some of the lines that you can add to a triangle. Some of them you can add to any line segments, but mostly we'll be looking at these in the context of triangles. We'll be looking at three types of lines or line segments that you could add to a triangle. The first is called the median. The second is called the perpendicular bisector, also sometimes called the right bisector. And the third is called the altitude. So first we're going to look at a median, and we'll use this triangle CDE here. And a median is, by definition, a line segment that goes from one vertex, right? And you know a vertex is one of the corners. One vertex of a triangle to the midpoint of the opposite side. So right now we're going to draw the median from vertex E. Here it is right there. So if the median goes from vertex E to the opposite side, and where does it hit the opposite side? It hits it at the midpoint. We could calculate that midpoint, but I'm pretty sure that you would agree that that midpoint is right here. If we did the math, we could figure it out, but here it looks like it's at -7, -1. And of course, this would be the midpoint of CD. So we are drawing a line that goes from E to that midpoint that we calculated, something like that. A perpendicular bisector is, well, what it is right in its name. It's perpendicular, so it goes through a line segment at a right angle, and it's a bisector, so it cuts a line segment in half. So by definition, we would say a perpendicular bisector is a line that goes through the midpoint of a line segment. Okay, in this case, our line segment is probably the side of a triangle at a right angle, okay, or perpendicular to it. And so I'm going to draw the perpendicular bisector of side DE. So since it's a bisector, it has to go through the midpoint, which is here. The midpoint of DE is -2, -1. I could calculate that, but I think that's true. I also think it's true that if I look at the slope of DE, that looks like it goes down 1, 2, 3, 4, 5. So it has a rise of -5 for every run, 1, 2, 3, 4 of 4. So I think the slope of DE looks like it equals -5/4. Now, my perpendicular bisector is going to go through here at something like this, at a right angle, right? Now, if I want to be really accurate, I know that it's going to have a perpendicular slope to that. So the slope of my line is going to be perpendicular, so it's going to be the negative reciprocal. It's going to have a slope of 4/5. So from this point, I can go up 1, 2, 3, 4, and 1, 2, 3, 4, 5. Just made it on there. And that looks like it's going to be right here. I could also go in the other direction, down 1, 2, 3, 4, and run 1, 2, 3, 4, 5 here at -7, -5. Looks like it's right, not there, here. And then I could draw a line through my midpoint and perpendicular to that side. which makes my perpendicular bisector my right bisector, both of those things. It goes through the midpoint and it goes perpendicular to that side. You'll notice it doesn't necessarily go through any other points. It misses this vertex. It doesn't have to go anywhere near it actually, as long as it does the things that it's supposed to do through the midpoint perpendicular. I would point out as well that the perpendicular bisector is not a line segment, it's a line, so it goes entirely through the triangle and does not stop. The third line that could be added to the triangle, or a line segment in this case, is called the altitude. And the altitude is the shortest distance from one vertex to the opposite side. So if we were to come, for example, from vertex D and try and make our way from D to side CE, well, there's a couple different paths we could take. We could go there, that way, we could go this way, we could travel like this. And by examining a couple different ways of getting in a straight line from D to this side, I think it's not too much of a stretch to say that the shortest distance will always happen when we come at it directly. And by directly, we mean that we will meet it at actually a right angle. So it's worth noting that it will meet that side at a 90-degree angle, or a right angle. Now you've seen altitudes before. Previously, they've been called the height of the triangle. Now, like any of these lines, you could draw them from any side, but in this case, we're going to go with the easy one, and we're going to draw the altitude from vertex D. And fortunately, in this triangle, it so happens that the side that we are heading to is exactly a horizontal line, so that means our altitude in this case will be a vertical line. And it will come from D, it will come down to the opposite side, and it will meet at a right angle. And so there we go. We have a triangle that has a median here. It has a perpendicular bisector here, and it has an altitude here. So just really quickly, we could kind of show what we've done here by saying there's three possible aspects that the lines and line segments we've just talked about could have. It could go through a midpoint, It could come from a vertex, and it could meet or cross at right angle. And so if something goes through a midpoint and it meets at a right angle, then it must be a perpendicular bisector. If it were to go through a midpoint but come from a vertex, well, it must be a median. And if it were to meet or cross at a right angle but come from a vertex, then we must be talking about an altitude. Think you got it? Well, the other triangle you have is triangle FGH. On triangle FGH, why don't you see if you can draw the following. See if you can draw the median from vertex F. See if you can draw the altitude from vertex F. See if you can draw the altitude from vertex G. And see if you can do the right bisector or the perpendicular bisector of side GH. Give it a shot. Good luck.